over and push. You get a shower of ice cubes, all frosty dry and ready to use.
Once dependent on daily ice deliveries that melted within days and left food perpetually at risk of spoiling, the American kitchen by the early 1920s was on the verge of a fundamental change. One driven not by a new idea, but by the first practical application of mechanical refrigeration technology at a price households could begin to consider. The machines that delivered that change were built by hand, in factories that combined the precision of machine shops with the craftsmanship of furniture workshops, producing appliances that had to function as reliably as industrial equipment while looking presentable enough to stand in a family kitchen. Getting both right simultaneously was more complicated than it sounds. This video will take you inside refrigerator manufacturing in the 1920s to uncover exactly how wood, cast iron, copper tubing, and electrical components were brought together into a working domestic refrigerator, why each stage of the process demanded precision across materials and disciplines that rarely overlapped in other consumer products, and how an appliance that cost more than a new automobile in 1920 became a mainstream household purchase by the end of the decade. Right now, let us explore this remarkable manufacturing story together. Every refrigerator manufactured in the 1920s began as a detailed engineering drawing produced by designers, working simultaneously on two problems that pulled in different directions. The mechanical system, compressor, condenser, evaporator, and refrigerant circuit, had to be engineered for reliable continuous operation under the variable demands of domestic use. The cabinet surrounding it had to be dimensioned to fit kitchens designed around ice boxes, insulated thoroughly enough to make the mechanical system economically viable, and finished to a standard acceptable as household furniture. Cabinet wall insulation, typically between 3 and 4 inches of cork, mineral wool, or compressed fiber, was determined by the heat load calculation for the intended climate zone and the cooling capacity of the paired compressor. Interestingly, the insulation specification was frequently the most commercially sensitive decision in the entire design process, since thicker insulation improved efficiency but increased cabinet size and material cost, while thinner insulation reduced cost but increased compressor runtime and operating expense for the consumer. From the engineering department, approved drawings passed to the production floor, where cabinet construction and mechanical component manufacturing began as parallel operations. The outer cabinet of a 1920s domestic refrigerator was constructed using hardwoods, principally oak and ash, selected for dimensional stability after drying, resistance to kitchen moisture conditions, and the quality of painted finish achievable on a close-grained surface. Incoming timber was inspected for structural defects and moisture content before being cut to the panel dimensions specified for each model. Cut panels were dried to a stable equilibrium moisture content before being passed through hand planes and machine planers to achieve the surface flatness required for tight joint assembly. Cabinet frames were constructed using mortise and tenon joinery, the same technique used in fine furniture of the period, pulled under clamp pressure with hide glue and allowed to cure before panel installation. The assembled outer shell was sanded progressively through finer grits before receiving a primer coat in preparation for the enamel finish applied in later production stages. Front panels and door frames received particular attention, as these surfaces were most visible in the finished appliance and most exposed to handling during daily use. At this stage, the wooden cabinet shell, though structurally complete, contained no insulation, no interior liner, and no mechanical components, a fact that made it, to any casual observer, indistinguishable from a well-made kitchen cupboard. The insulation installation that followed would determine whether it remained merely decorative or became a functioning refrigerator. With the outer cabinet shell completed, workers packed the wall cavities with insulating material using a process that required considerably more care than the description suggests. Corkboard sheets were cut to fit each wall section and installed in layers, with joints staggered between layers to eliminate direct thermal bridges through the insulation thickness. Loose cork granules or mineral wool were packed into corners and irregular spaces that sheet material could not fill completely. Each cavity was filled to uniform density before being sealed, as voids or compressed sections created local thermal weaknesses that disproportionately affected the overall insulation performance of the finished cabinet. Following insulation installation, the interior surfaces were lined with galvanized sheet steel formed and fitted to the cabinet interior dimensions. As the decade progressed, porcelain enamel on steel became increasingly common for interior linings, offering improved resistance to food acids, easier cleaning, and a brighter appearance that consumers preferred. Interior shelving, drain channels, and evaporator mounting provisions were incorporated during the lining stage before the cabinet moved to mechanical assembly. The compressor was the most mechanically demanding component in any 1920s domestic refrigerator, and most refrigerator manufacturers either produced their compressors in dedicated foundry and machine shop operations or sourced them from specialist manufacturers. Cast iron was the primary compressor housing material, selected for its machinability, vibration damping characteristics, and pressure containment capability. Compressor housings were cast in iron foundries, allowed to cool and stabilize dimensionally, then transferred to machine shops where cylinder bores, bearing surfaces, crankshaft journals, and valve seats were machined to the close tolerances required for efficient compression. Pistons, connecting rods, crankshafts, and valves were manufactured separately and assembled into the housing with careful attention to clearances that determined both mechanical efficiency and operating noise. Completed compressor assemblies were tested for mechanical operation before being transferred to the refrigerator assembly line, a step that reflected a straightforward commercial reality. A compressor that ran noisily or inefficiently in isolation would be no better once installed in a cabinet, and considerably harder to access for correction. The refrigerant circuit, condenser coils, connecting tubing, and evaporator was fabricated from copper, selected for its formability, thermal conductivity, and resistance to corrosion by the refrigerants in common use during the 1920s. The primary refrigerants of the period were sulfur dioxide, methyl chloride, and ammonia, each offering effective thermodynamic performance, but presenting handling hazards that required careful management throughout manufacturing and installation. Copper tubing was bent to shape using forming mandrels that prevented kinking, then joined at connection points by brazing rather than soldering, as brazed joints offered the pressure resistance and leak integrity the refrigerant circuit required under operating conditions. Each completed coil assembly was pressure tested before refrigerant charging, as any leak in the sealed circuit would result in loss of refrigerant and failure of the cooling system. The quantity of refrigerant charged was specified by the system design. An undercharge reduced cooling capacity, while an overcharge increased operating pressures beyond the design limits of the circuit components. The electrical system of a 1920s domestic refrigerator consisted of the drive motor, a starting relay or switch, the thermostat controlling compressor operation, and the wiring connecting these components. Motors were typically single-phase induction types operating on the 110-volt AC supply, becoming standard in American homes during this period, with power ratings between 1/4 and 1/2 horsepower, sufficient for domestic compressor loads. Kelvinator, one of the leading manufacturers of the period, had introduced automatic thermostatic temperature control as early as 1918, a feature that allowed the compressor to cycle on and off in response to cabinet temperature without manual intervention. This automatic operation distinguished electric refrigerators from the ice boxes they were replacing in ways that consumers found immediately compelling, and it became a standard feature across the industry during the 1920s. Following electrical installation, the compressor and refrigerant circuit were mounted into the cabinet, mechanical and electrical connections were completed, and the door was hung and adjusted for seal compression. The finished door, built around a hardwood frame packed with insulation and lined with metal, was heavy enough that its chrome latch required deliberate engagement, a physical reminder, as every owner quickly learned, that the cold air inside was worth keeping there. Each completed refrigerator underwent operational testing before finishing. The compressor was started and the system run through a full cooling cycle, with interior temperatures monitored to verify that the cabinet reached and maintained the specified operating range for domestic food storage. Refrigerant circuit integrity was verified under operating pressure, electrical connections and thermostat operation were checked, and door seal performance was assessed. Units failing any test returned to the assembly area for correction before retesting. Units passing operational testing received their exterior finish. Multiple coats of enamel paint applied over the primed cabinet surface, dried between coats, and finish sanded to produce the smooth, uniform appearance that consumers expected from an appliance at the premium end of the household market. Chrome trim, brand identification plates, and hardware were installed before a final inspection cleared each unit for packing and shipment. In 1922, a domestic electric refrigerator retailed at approximately $714, compared to $476 for a new Model T Ford, placing it firmly beyond the reach of most wage-earning households and establishing electric refrigeration as a luxury purchase rather than a standard domestic appliance. By 1929, Improved manufacturing efficiency and growing production volumes had reduced prices sufficiently to bring refrigerators within reach of middle-class consumers, with annual American production reaching approximately 800,000 units, a volume that would have seemed implausible when the first domestic models reached the market less than a decade earlier.